Hello everyone, this is Mr. 13 Things, or Silence Did Good, depending on which channel I choose to upload to. And we're continuing on or finishing up with the discussion of quaternion rotations of points. We've done it this way. We've shown you kind of the one way to do it within SketchUp using the drafting tools. We've done it by hand, and remembering the key thing about doing a quaternion rotation on a point is, one, the point is defined by a quaternion that has a real value equal to 0, and then the I, j, and k value is equal to the x, y, and components of the point. And then that point is kind of sandwiched in a sandwich product of a rotation quaternion and its conjugate. That doesn't mean anything to you. That's fine, probably. It is worth digging back into, but what we're doing right now is we're going to look at some Ruby code that essentially does the same thing at a more abstracted level. And so we're trying to introduce my kids to the concept of abstraction. Once you kind of dig in and learn the cool, fun, crazy mathematical arts of what's happening in your Xbox, you can probably start working on your brain deciding to not remember particular things and only going back to them when you need to, but understanding the higher order concept. Higher order concept for rotations, quaternion rotations, is that you rotate a body by rotating its faces, which are defined by edges, which are defined by points, about an axis vector, AXIS. And that said, we're going to look here at, we're looking at some Ruby code in the code editor. There's now something called development tools. I'm running SketchUp 8. I'm going to show you first how you start any SketchUp. When you get into the starting drawing, you want to always double check, like any machine, double check that you've got your format correct. Make some assumptions, what are your settings? So in this case, we have it as decimal and inches. I'm going to recommend for troubleshooting you do lots of things that way because, believe it or not, the base unit in SketchUp is the inch. So if you're troubleshooting programming, it makes it a lot easier in some ways to just deal with everything in inches. And because it's a 3D drafting platform, it's not that big a deal. It's just a big database to do some sort of scale factor. Remembering, of course, that there are 2.54 centimeters in an inch. That is an exact number. For the surveyors out there, we can get into the discussion of survey inches at another time. One of the declarations is that, in fact, when they did the metric system to English system, is that the 2.54 centimeters equals 1 inch. It is declared as an absolute. The other one that's an absolute, just so you know, is the declaration of a meter, is now defined as the distance that light travels in the reciprocal of 2.99792458 times 10 to the 8th meters per second. So think about that. Look it up in your standards. That said, all right, we've got the units defined, and what we're going to do now is then look at the code. It's interesting how SketchUp deals with lots of different things. One is the construction point. So I'm going to go through this code pretty quickly. What I mostly want to show people is that a large part of what I put in front of you is just definitional. So, and I do not have this written down with functions and the like, so there's a lot of repetition in the code here. But if you look at what it takes to do a quaternion rotation by hand, you can understand why people started to learn to do them with computers. You'll also know that a lot of this nowadays is done in the cloud, so you can, if you have a robot, you can keep some of the computation outside the robot. In other words, up in the cloud. That reduces your battery requirement and your energy requirements. Depending how far away you are, that might not work if you're on Mars. You might have to do some computation in place. So that said, what we've got here is a Ruby code editor. We first define a variable called model. That is basically the model we're working on. We then have the set of all entities in the model is called entities. The set of all the selections in the model selection is called selection. The definitions, most of these are not necessary, but I just do them over and over again. You can, later on, you're going to see as you get down into recursion, you're going to have subsets of entities called something else. So this is essentially the model is what you're working on, and then the entities are those pieces in the model that you're working on. The view is, the active view is defined, and now here is what we're doing, because what we are going to do is we're going to rotate a given point of 1, 0, 0 about an axis that is defined by a 60-degree angle in the XY plane, and we're going to also rotate it 60 degrees. So you see that here, this is the angle that I'm calling in terms of the rotation, the axis angle, and this next statement here converts that to radians. Very often, depending when you're working, it's not a bad idea just to start in radians and check back to go into degrees, but most of you are probably thinking in degrees, unfortunately, for way too long. Getting kids to understand that a radian is just a basic simple ratio, and that there are 2 pi radians in a circle is something you might want to think before you throw them in the spreadsheets in 5th grade in today's modern educational environment. All right, so we've got the angle in the XY plane, and then we convert that. Now we have the rotation angle. This is a positive 60 degrees, and that is converted. So right now we have 2 variables that we're really dealing with: angle and gradient in angle in radians, and the rotation angle in radians. We now then define a point, a construction point, this way. We're going to add the construction point at a location of 1 in the x0 and y and 0 in the z. For me, even though I'm an old guy, or a young guy, until I kind of got into SketchUp, and the cool people from SketchUp, which was started in 1999, force you to be in 3D, I didn't quite get that that's the way the world was going. So I add the point at 1, 0, 0. I don't actually need this one. I'm going to get rid of that. The view refresh. I then define a transformation, and the transformation is defined, basically this is the closest thing that we have to the Quaternion definition. So we have, it's defined by a origin point, an angle of the axis, and then the angle of the spin. Of course, this is then going to go ahead and do some Quaternion calculations, but it's basically the way that you're kind of going to do any kind of rotation when you're doing Quaternion calculations. You need to know the axis of the spin and then the rotation of the spin. And what you'll notice here is that these are all input. These are calculating off of the input values here. I then transform, in other words, I apply this transformation, much akin to applying multiplying a matrix times a vector. You see the vector here is given as the point is a row vector, though in our heads we want to think of it as a column vector. We're going to apply it, and then we're going to report out the position in another window. So as I do that, and we can compare that, whoops, we're going to compare that when we're done here to what came up in our calculations by hand, because we are doing the same calculations as our outline in the previous videos when we're going through it by hand. I'm going to go ahead and bring up the Ruby console. Hopefully there, is it around? There it is. I'll bring it up through there, and you can see there's that 0.625, 0.216506, and minus 0.75, and take my word for it, that is what you get when you do this calculation by hand. What's beautiful about now, and the beauty of programming, is that you might not want to do that. So I'm going to go ahead, you might want to not do it by 60 degrees. You might want to only do it by, let's see if I can think about this, 57.13, and the angle of rotation might also only be 57.13. Right, what I'm going to do is, because of the way this code is written, I'm going to go ahead and erase this out, and now I'm going to run it again. And you see the point there. Now, what's also great about programming in an environment like this is that you have an ability to kind of see what it's done more or less right away. When we do this in the Khan Academy computer science framework, you'll actually be able to see the point moving as you change the variable, which is just a very, very cool thing. That's programming in then JavaScript and processing JS. So what I'm going to do here is I'm going to go ahead and show you what you also have an ability to kind of jump back and forth. The unfortunate thing is that's text, so because that construction point is kind of an odd entity, What you can do to trick it out, though, is you can draft a line from there and then go ahead and erase out the point. You do that by staying on top of it, right-clicking, hitting an erase, and now edit, undo, erase. So I'm going to do that. Don't want that. Don't want to do that. Erase. And now the same way as I go here and I do that, you can see somehow I blew what happened there. Oh, I didn't blow it, because that in fact is what happened when I then converted or rotated. And at 57.13, I should have done that, but that's about 57.13 is about what a radian is in degrees. But do not remember that. You remember pi radians equals 180 degrees, or 2 pi radians equals 360 degrees. But more likely, you just want to remember that a radian, when you measure something in radians, you're measuring a ratio. And the ratio you'll see is the distance you walk along the outside of the circle compared to the radius of the circle. So that said, one more time, here's what the code looks like. The next coding we'll do will actually show you how to do the coding, and it'll be much more intense, though, in other words, less abstracted. So we'll break down what's happening here in this which is basically a transformation process. So we had 1, 2, 3, 4, 5 lines of basic repetitive code you'll have in any kind of Ruby sandbox application to a database. We've defined 2 angles and converted them to radians. We could have just as easily put them in originally as radians. We could have used a function to do that. There is one. It is nice very often just to do this calculation right here so you can see what's going on. We defined a construction point at a given vector and a given point in 3D space. We defined a transformation, rotation transformation, basically by defining the axis, the point of origin, the axis, and then the angle of spin. We performed that, and then we reported out what it had done to the entity or the point's position. That is an abstracted way, and we'll look at that in a bit of a chart, to do quaternion rotations within SketchUp. It's essentially embedded in the definition of a transformation for rotation. Thanks for listening.